Take notes, and I will tell you, we will not complete this packet in its entirety. It was one of those, I put the last page on it, and it was like, we might get to it, we might not get to it, just depending, and that's okay. So let me switch it. You guys can see that a little better. I don't know why the black and white tends to show up a little bit better, but it doesn't do really good on those full color pictures. All right, so we are talking about probability. And whenever you're talking about probability, you are actually talking about how likely an event is to occur. How likely an event is to occur. And a probability of an event is measured somewhere between 0 and 1. So whenever you are talking about the probability of 0, do you think that that's the impossible or it's certain? If I tell you the probability is 0, do you think that that event is impossible or it's certain? All right, impossible is 0. All right, so this is impossible. So this means that something never happens. So if the probability of something is 0, that means that it never happens. And if the probability is certain, or 1, that means it always happens. And honestly, do you think that there's very many things that we can say will always happen or never happens? No. Not very often. Most of the time we are going to have something between 0 and 1, and you are probably going to see probabilities expressed in this case as a fraction or as a percent. And I'm okay with you writing them as percents. But if you write, I'm going to say, let me give you an example. Hang on just a second. All right, so a fraction, you would see something like 67 out of 100. Now, if you have a fraction, how do you get the decimal for that? What would I type in the calculator to get the decimal? If we have a fraction, how do we convert that to a decimal? No, if I just want to know the decimal of 67 over 100. Yeah, we divide it. So you would take 67 divided by 100, and that would give you 0.67. So those would be two acceptable answers. If I told you something was 67 out of 100, 67 out of 100 times something would happen. Now, this is the fraction. 0.67 would be a decimal. Now, how do I turn a decimal into a percent? Where do I move the decimal?
2 places to the right.
2 places to the right. So if you move it 2 places to the right, then that becomes 67. Now, if your number is bigger than 1, it has to be a percent. So don't forget to put that. You can't just say the probability is 67. Probability, if you want to write it as a decimal, that's okay, or if you want to write it as a percent. So if I told you something happened 67 out of 100 times, all 3 of these mean the same thing. 67 out of 100 is a fraction, means the same thing as 0.67 as a decimal, which means 67%. And I will try on assignments to be specific on what form I want the answer in, but they all do go hand in hand. So whenever we are doing probability, sometimes we actually collect data to determine a probability. And so, I don't know, just an example I can come up off the top of my head just because there's brackets all over the room for my stats class. In this class, I could go to all the brackets and tally up how many games we've guessed correctly. And then I could give you the probability that you would pick a game in the NCAA tournament correctly. So if you are actually collecting data, the number of the times the event occurs, and the event is something that you want to happen, and the number of trials is how many times you would try to make that event happen. And so we're always taking the part divided by the total. So if we look at that first example, it says we have 60 vehicles in the teacher's parking lot today, which is probably pretty close. And it says there are 15 pickup trucks. Probably not accurate information if we actually went out into the parking lot. I don't know if any of you guys park in the back or if you guys all park at the SAC. For those of you that drive, say, anybody walk by the teacher's parking lot and notice anything? What do you tend to see in the teacher's parking lot?
Cars.
Well, what kind of cars?
Not trucks.
Not trucks. So what kind of cars do you see? I'm going to say mainly SUVs. Because they're moms. Say my girls decided to name my van this week the Mom Bomb. Why, I don't know.
Soccer mom.
Yes, I am official. Like I've had my van since Lucy was a baby. Kinsley was 2.
That's what my mom always used to buy for me.
Yeah, because little kids like fling doors open and hit other people's cars in parking lots, and the doors slide and they're automatic, and it's a game changer.
I hated the way they looked.
I don't know.
They were pretty comfortable.
How many trucks is there out there? Like 2?
Okay, so I would say if we went out to the teacher's parking lot right now, we would see. Oh, who drives truck? Well, Mrs. Tao drives a truck, but she's not here.
They drive the black Ford.
This house here.
Is she back today?
Yeah.
What?
Yeah, she's here.
All right, so her truck's outside. Mrs. Tao, Mr. Ladoon.
Is she driving it though?
Autry does. It depends on where. If he sometimes rides with Mr. Miller.
Really?
I'm trying to think. There's one more truck. Whose is it? I don't know, but in our teacher's parking lot, there is definitely not this many trucks.
More boy driver truck. They don't park.
Yeah, they don't park in the teacher's parking lot. They park over.
By the gym.
Yeah. So if, let's just say this was our parking lot. It's realistically probably not. But if we wanted to go through and say, what is the experimental probability that we're going to go out in the parking lot and the vehicles will be a pickup truck? So the first thing we are going to ask is the probability that it is a pickup truck. So we need to talk about notation first. Do you guys see this right here on your paper where it says P and then in parentheses it's the event? So in this case, we're trying to figure out that the probability that it is a pickup truck. So the probability, P stands for probability. In this case, we want it to be a pickup truck. And if you just want to write truck, that's fine. You don't have to write. So the probability, if we are finding the probability of a going out and, I don't know, just say like pick a random parking spot, what's the probability that the vehicle in that parking spot's going to be a truck? The probability is the number of times the event occurs. So how many times did you see a pickup truck in the experiment? You want to say how many trucks were there? 15 out of how many? All right, so that would be 15 out of 60. So that would be the fraction. Now, could you reduce that fraction?
1/4.
1/4.
1/4.
All right, so it does reduce by 15. You could write it as 15 over 60. You could reduce the fraction. Now, what's the decimal for that?
0.25.
0.25. Or what's the percent of that?
25.
All right, now I would accept all of those answers. I actually don't care if you reduce fractions. All right, now I've got something to show you. I'll say, can you guys see my you guys can't see that calculator screen
Oh, we did.
for just a second.
Yeah, there, maybe, yeah.
And I'll say, this light right above my head is just not my friend. Let me see if I can. All right, so this might be just a little bit better for this. Now, I will tell you guys, in the next couple weeks, I will be introducing you to my graphing calculators. I keep them over here. There will be a checkout process. But I want to show you something. All right, so if I type in 15 divided by 60, it automatically gives me the decimal. Now, most of you guys probably know that 0.25 is 1/4. But I will show you there is a way on this calculator. There's some buttons we can hit, and it has a menu. Do you see that says fraction?
Yeah.
You can hit enter, and it'll convert your answer to a reduced fraction. So we will be working with that, not today, but we will be working with that in the future. All right, now, I don't know if you noticed there was a second question there. So we answered question 1. Now there's a question 2. What's the probability that it's not a pickup truck? All right, and so if it is a pickup truck, it's 15. So the probability that it's not a truck would be, and how did you get 45?
60 minus 15.
Yeah, 60 minus 15. So if there's 15 pickup trucks, that means there's 45 vehicles. Subtract the total minus 15. 45 out of 60, or 3/4. What's the decimal for that?
27.5.
And the percent?
75%.
All right, do you guys want to try example 2 on your own really quick? All right, so I will read it and I will help you with the notation. It says a softball player got a hit in 20 of her last 50 times at bat. What is the experimental probability she will get a hit? So what are we trying to find the probability of? All right, probability of getting a hit. So the notation. Hey, anytime you're finding the probability, Lucas, what is the letter we're going to use for probability?
P.
All right, the P. And then inside the parentheses, we always write the event. And in this case, we are trying to find out the probability that when the softball player goes to bat, she will get a hit. So I want you to tell me the fraction, the reduced fraction, the decimal, and the percent. So the fraction, the reduced fraction, the decimal, and the percent.
Done.
All right, what's the fraction we start out with?
20/50.
20
Over 50.
over 50. 20 out of 50. Now, this one we can reduce by 10, right? Just get rid of the zeros. What's that reduced to? 2/5. What's the decimal for that?
0.4.
0.4. Now, I don't have 2 places to move my decimal.
Well, you just
Add a
move a 2
zero.
and add a 0.
All right, we add a 0. So if I move 0.4 2 places to the right, add a 0, and we got 40%. How'd you do? All right, so I will tell you guys, we might come back to this tomorrow. I can't guarantee that. The simulations, I don't really like random number tables. They're kind of outdated. So I'm actually going to skip over that for the moment. Let's go to theoretical probability and sample spaces. So I will tell you guys, most of the time, it's time consuming to collect data. And so instead of actually collecting the data, a simulation does take place. And whenever you are doing a sample space, you want to just consider all of the possible outcomes of an experiment. So whenever you're listing a sample space, you're just listing all of the possible choices. So do you guys remember when we did the permutations and the combinations, like the Scrabble letters, and we came up with all the different ways that we could rearrange those letters? That was a sample space. That's what we created. The probability of having multiple or different combinations or different outcomes. Now, when each outcome has the same chance of occurring, those are equally likely. So let's talk about a number cube, and I'm really sorry that the numbers don't show up there. A number cube is basically a die. Like a single is a die, plural is dice. So if you're rolling a number cube, what are the different, what can happen when you roll a die?
You get either 1, 2, 3, 4, 5.
Okay, so your sample space would be 1, 2, 3, 4, 5, 6. If you're just rolling a single die one time, or a number cube one time, those are the possible outcomes. Now, are these equally likely?
Yeah.
You know, say, why are they equally likely? All right, it's a cube. One thing about a cube, all the sides are equal, correct? So it's not like they do have weighted die that make it where one thing lands on the bottom, but if we're going to assume that it's a fair one. So yes, these are equally likely. All right, so in a theoretical probability, it's a lot like experimental. We're still calculating probability. We are going to, the numerator is the number of outcomes that you're looking for, and the denominator is the entire sample space. So let's just think about this standard number cube. All right, so for each one of these, and you don't really have to write all of these out. I'm just explaining this in full detail. So for part A, if we want to know the probability that we are going to roll an even number, you guys tell me, what do you think the probability of that is? If I roll a single die, what's the probability the number that I'm going to land on is even? Okay, half, 50%. Now, if you think about this, the entire sample space, these are all of our choices. Which one of these numbers are even?
2, 4, 6.
2, 4, and 6. Those are the even numbers. So the probability of rolling an even number, the amount of even numbers in our space is 3 out of 6, which ends up being 1/2 or 0.5 or 50%. Now, do you think I want you to write out the sample space and circle those every time? You know, say, I want you guys to just go straight to the fractions, but I do want you guys to see this. Now, what's the probability of rolling a 7?
0.
Why?
There's no 7.
All right, it's impossible. There's not even a 7 on there, so it's impossible. So the probability of rolling a 7 is 0. Is there a problem? All right, now for this last example C, probability of rolling an even or a multiple of 3. So let's think about this sample space here. We have 6 possibilities for our numbers that we can roll. Okay, so we've already talked about even numbers. We know that evens are 2, 4, and 6. But it also says it could be a multiple of 3. Does that include any other number?
3.
3. All right, so 1 and 5 are the only numbers that aren't included here. So the probability of rolling an even or a multiple 3, there's 4 possibilities out of 6. What does 4, 6 reduce to? 2/3. Now, if you type in 4 divided by 6 in a calculator, you get a repeating decimal. I am going to tell you, for our class, we are going to round to the nearest. We are going to go 3 places after the decimal. So if you type in 2/3, it's a bunch of 6s, right? So it'd be 6, 6. The 6 would round up for the last one to a 7.
Close one, guys.
All right, now whenever we move our decimal 2 places to the right, I do want you to keep that. So it'd be 66. The decimal now is 0.7%. All right, we're almost done. Now, say, do you guys have any questions up to this point?
It's a lot easier than what we did.
It is a lot easier.
I was scared for a break. I'm like, I'm not passing these.
No, probability is one of my favorites. No, and I will say permutations and combinations, they're really not that bad. I promise, they're not. And for those of you that are taking AP Stats, don't get, if you guys decide that you want to take AP Stats your senior year,
Oh, you can only take it as a senior? You don't have to worry about taking it.
Well, I am taking it, but thank you very much.
well,
You can't take it this year, but
Next year.
no, if you're Core 40, you do Algebra 1, Algebra 2, Geometry. So then your senior, yeah, so your senior year is what some people, some sophomores that are in here haven't taken geometry yet. So
But if you double up on them as a sophomore, you could have taken it as a junior. But
yeah, but I wouldn't recommend that. Okay, do you guys have any questions? But I want to let you guys know the permutations and combinations, we really don't even work with permutations at all. We focus just on combinations, and I let you use the calculator. So the calculator, I don't know, like, I can tell you, like, if I want to do like 10, choose 4, like, we use the calculator. Like, that's what we do in AP Stats. We do it on the calculator. But you have to know where those numbers are coming from. All right, so we are going to move on to cards. Cards are one of my favorite ways to talk about probability. So on these, we are just going to answer in fractions. All right, so this is just information. This is actually not part of the question. This is just to show you in a deck of playing cards. So there's 52 cards in a deck. And it's just telling you that there's 13 cards. There's ace, king, queen, jack, and then the numbers 10 down to 2. Suits are like the little symbols that are on the cards. I know some people probably are familiar with this, some people are not. So there's 2 black suits. There's clubs and spades. Spades kind of look like a shovel. Clubs, I have a friend that calls them puppy paws. Like whenever we're playing euchre, they'll be like, "What's Trump?" And we're like, "Puppy paws," because like when you say clubs, he's like, "I don't know what that means." So we got puppy paws and shovels, and then diamonds and hearts, I think, are the easiest ones to tell. So if we are looking at this, the first thing I want to ask you, out of the 52 cards, what's the probability that I'm going to pick a king? How many kings
4.
are in the deck? All right, where are the? So there's definitely a king, but there is a king of clubs, a king of spades, a king of diamonds, and a king of hearts. So in this case, our probability would be 4 out of 52. Now, can we reduce that
Yeah.
to what? 1 out of 13. And we're not going to do decimals and percents on these ones. We're going to leave them just as fractions. So 4 out of the 52 in the entire deck, or 1 out of 13. All right, now what about a face card? Which ones are face cards? All right, so face cards are king, queen, jack. So how many kings are there? We just determined that. So then how many queens are there? How many jacks are there? So what's the total there?
12.
12 out of 52. And we can reduce that. We can reduce it by 4. What do you think that reduces to?
3 over 13.
3 out of 13. Divide them both by 4. All right, now I like this next question. But before we do C, do you guys have any questions on A or B? All right, this one is a good one. All right, it says there's a probability of a heart or a probability of a 10. All right, so first of all, how many of the cards in the entire deck are hearts?
13.
13 hearts. Because there is a heart of an ace, king, queen, jack, 10, all the way down to 2. So 13 total. And it says or a 10.
17.
Oh, let's think about
16, because you already counted your other 10.
Okay, so let's think about this. We have all of the hearts. Now, how many additional 10s, once the hearts are gone, how many 10s are still in the deck? 3.
4. Just kidding.
All right, so Luke, I'm actually glad that you said that because I don't know if you guys heard what they were saying back here. I think Luke thought there's 4 10s, but then Lane, why is there only 3?
Because you already took one of your 10s and you counted your hearts.
Yeah, when we counted the hearts, the 10 of hearts was included in that set of 13. So right here, these extra 10, this is where we're talking about our clubs, our spade, and our diamond. The 10 of heart was already included, so we just have to include the other 3 hearts. And so this gives us a total of 16 out of 52, which we can reduce by 4. And what do we get? 4 out of 13.
Could we take the percent of these or not?
I mean, you can do the percent, but I'm just going to leave these as fractions.
You guys ever look at how many like possible outcomes a bracket could be?
It's a mess.
Is it crazy?
Yeah, it is like 2 to the 63rd power.
That's a lot of numbers.
Yeah. Like we're talking like you have a better chance of winning the Powerball than you do picking a perfect bracket.
Really?
Yeah. Like a way better chance.
That's awesome. Open up a bracket position.
All right, so example 5 is going to be our last one for the day. And you guys do not have an assignment today. You'll have an in-class assignment tomorrow. All right, so this last example, it says we're opening a bag of Jawbreakers. And I don't care what you say, Jawbreakers do not taste the same.
I think a lot of people are the only people that eat Jawbreakers.
I like Jawbreakers.
Sorry.
What are you trying to say?
My grandma eats it all the
What are you
time.
trying to say? Trying to say I'm old?
Yeah.
So, in this like in this Jawbreaker bag, there's 15 red, 10 orange, 8 green, 7 purple, and we want to know the theoretical probability of this event. We're not actually going to open up this bag. That's why it says theoretical. What would be the probability that we would get red or orange? So first of all, how many red and how many orange are there if we put those together? 25, because there's 15 red and 10 orange. So that would be 25. But what's our bottom number?
42.
Huh?
42.
Where'd you get 42
Add them
from?
all up.
Okay. I don't think 42.
I got 40.
I agree with Kobe there. All right, so let's think about this. 8 plus 7 is 15. 15 plus 15 is 30, plus 10 is 40. So there's 40 total. So 25 out of 40. What could I reduce that by? Or actually, let's just go straight to the decimal. 25 out of 40. Let's go straight to the decimal. 25 out of 40. What's the decimal for that? 0.625. Now, if I wanted to write that as a percent, I would move it 2 decimals to the right and get 62.5%. Now, I will tell you tomorrow on your assignment, I will tell you in the directions for each problem, like if I want the answer as a decimal, as a fraction, or as a percent. So just make sure that you follow those. All right, now what's the probability that it would not be green?
32 out of 40.
Okay, can someone tell me how you got 32?
Subtract 8 from 40.
Okay, so some people say, well, there's 40 total. Take away the green, which is 8, to get 32 out of 40. How many of you guys thought about it that way? Anybody think of it a different way? If it's not green, what's another way you could get 32?
Add them all besides the green.
All right, you could add them all up besides the green. So some people would say, well, I'm just going to add up the ones that are not green. So 15 red and 10 orange is 25 plus the 7 purple. So some people add up the ones that are not green. Some people take the total minus the green. I don't care which way you do that, but what is 32 divided by 40? What's the decimal? 0.8 or 80%. All right, and last but not least, the probability of having something red or not orange. So how many of these are red?
15.
All right. Now, whenever we're talking about not orange, do we need to include the red again? So what other colors do we need to include here? All right, just the green and the purple, which would be 15, right? 8 plus 7. So how many are we working with total here? 30 out of 40, which hopefully you guys know that that's 3/4. What's the decimal?
75%.
0.75 is the decimal. Now what's the percent?
75.
All right, what do you guys think?
Pretty easy.
All right, do you guys think an in-class assignment tomorrow over this would be a reasonable thing to do?
Yeah.
Now, I do want you guys to know, do not lose your permutation and combinations packets that you guys had before spring break. I am doing a quick check on Wednesday. It'll be just a few questions for you guys to answer on Canvas on your e-learning. But I do want to let you guys know on Wednesday, I will not be in the building. My daughters both have doctor's appointments on Wednesday. And so if you guys do have questions over the e-learning, send me, ask. But you have to remember that, I am going to be on the road. So I have email on my phone, and I'm starting to figure out the teacher canvas on my phone. So I can work from my phone, but you just have to remember that, like, if I'm in my kid's doctor's appointment, like actually in the doctor's office or on the road, it might just be a little bit, like, normally I can answer within like 30 minutes, but if I promise on Wednesday, if you email me and I don't respond right away, I'm not ignoring you. I'm actually like taking a day off work. So, but if you need me on Wednesday, I will be available. And can I ask you guys to please, please, please put your calculators up at the end of class?
I guess.
Oh, come on.